Okay, this is the lesson on the paired sample t-test, otherwise known as the related sample or the repeated measures t-test. We seem to have our data open. We have 4 columns, one called participant, sex, pre-test, and post-test. There seem to be 10 different participants. If we click on variable view, we can see that the variable named sex refers to the participant sex. If we click on values, we can see that there is a 1 means man and 2 means woman. The pre-test variable is some score on a test before individuals are trained on whatever it is they're being tested on, while the post-test is the score on a test after being trained. We can see the numbers look a little different. Let's say we want to know whether or not the training is effective. You have this new training method and you want to know, does training actually make people better at taking a test? This might be the SATs, where you take an SAT class and then you take an SAT prep class, or for those of you considering graduate school or law school or med school, you take the GREs, the MCATs, the bar once you're in law school, and then you take a prep class, and we want to know if the prep class is actually effective at making you better. In order to do this, we're going to want to use a paired sample t-test. Our hypothesis is that the test does cause a difference. Our null is that there is no difference, that effectively the average here is exactly the same as the average here. So what we're going to do is we're going to go to Analyze, we're going to go to Compare Means, and we're going to go down to Paired Sample t-test. Now, we've seen here before the independent sample t-test, the one sample t-test, and the one-way ANOVA. We're going to do the Paired Sample t-test. And we're going to choose our 2 variables. It's saying, what pair do you want to compare? What is your first variable? What is your second variable? Well, our first variable is the score on the test, and our second variable is the score after the test. And all we're going to do now is click OK. Now we're going to get a couple different bars here. We're going to see our paired sample statistics. These are the means, the n, the standard deviation, the standard error of the mean for our before and our after. If we look at the test average before training, it's a 79.6. If we look at it after, it's an 82.4. That doesn't look like a large difference, but once again, we need to determine whether or not it is a significant difference. To be very honest, I think most of us would like to be able to increase our grades on tests about 3%. This box here is the paired sample correlations. It's looking for the correlation between your 2 levels of variables, the before and after. Generally, when we're doing paired sample t-tests, we're not going to pay much attention to this box. It's not particularly useful. We could, in fact, just get rid of it. Down here is the paired sample t-test information. And what we're going to do is we're going to go to pair 1, which is the score on the test before training, the score on the test after training. Had we included other variables, they're not in this data set, there would be more levels of pairs down here. And we're going to go all the way over to the very end, this section right here. And what we're going to be looking for is our t-value, our degrees of freedom, and our significance value, which once again is our p-value. So if our p-value or our significance value is less than 0.05, which it is, we would say that the groups do in fact differ. Our null hypothesis, which was that they don't differ, would be rejected. In this case, we would reject the null hypothesis. It looks as though with a t with 9 degrees of freedom, equaling negative 2.635, with a p-value of 0.027, the groups do in fact differ. And we can go back up here to the paired sample statistics to say that, in fact, the test is effective. People who took the test did better after taking the test than they did prior to taking the test. This is how you conduct a paired sample t-test.